Okay, let us just start the class. Today we'll be solving some examples from the multiplexers. Write down question number 1. Given f is equal to summation of the mean terms 0, 1, 2, 3, 4, 10, 11, 14 and 15. Okay, write down implement the given function. Implement the given function by using number 1 a 16 cross 1 mux, by number 2 a multiplexer having 3 data select inputs. 3 data select inputs. So we have done such kind of example in the class itself. So let us start solving it. So option A is you need to solve it using a 16 cross 1 mux. Okay, 32. Okay. Now 16 cross 1 mux means I'll directly take 16 cross 1 mux. Rule says if you are having 16 number of input line, then you should have 2 to the power, how much is 16? 2 to the power 4 is 16. So you should have 4 number of selection lines. So say S3, S2, S1 and S0. Now we are having 16 lines. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Out of the 16 lines, what are the mean terms present? 0, 1, 2, 3. 0, 1, 2, 3. Then 4, 5, 6, 7, 8, 9, 10. 3, 4, 5, 6, 7, 8, 9. अच्छा ये नहीं चाहिए फिर, ठीक है. So you are having 0 to 15 in together, altogether you are having 16 number of data lines. Now whatever the mean terms present, okay, जैसे कि you are having 0, 1, 2, 3, 4, they are present, then 10, then 11, then 14, then 15. These are present, so connect it to logic 1. Now the mean terms that are not present, they are 5, 6, 7, 8, 9, 11, 13. So you can connect it to logic 0. And this is your output F. Done everyone? Can I proceed for the next?
Yes, ma'am.
Now, second bit is you need to implement the same by using a multiplexer who is having 3 number of data select input. Okay. Now, question is you need to implement the same F. ठीक है. F पे आपका क्या है? F is 0, 1, 2, 3, 4, 10, 11, 14, and 15. So by default, number of select lines has to be 4. Okay. Now, out of these 4 lines, in the question itself is it has been mentioned that you need to take 3 number of lines as your select lines. So let say your f is a function of w, x, y, and z. Okay. So let x, y, and z are your select lines. Okay. So which one is left? W is left. So you need to map the W in terms of your input information. Okay. So what we will do, we will first take a mux whose select lines are X, Y, and Z. So the rule says if you are having 3 number of select lines, you should have 2 to the power 3, that is total 8 number of input information line. So it is I0, I1, I2, I3, 4, 5, 6, and 7. So it is the 8 cross 1 mux. This is the output F. Alright. Now, in order to implement this, what is the basic thing that we need to have? We need to have the truth table. Okay. So first you form the truth table W, X, Y, Z, 0, 1, 2, then 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then what will be the value of your F? F is 1 for 0, 1, 2, 3. So 0, 1, 2, 3 और 4 के लिए output 1 होगा. Then 10, then 11, 14, and 15. The outputs are 1. For all other value it will be 0. Alright. Then if it is so, you need to map the I0 to I7 in terms of your single available variable W. So what we will do, we will go for the mapping procedure. Okay. Mapping means we will have W bar 1, 0, 1, 2, 3, 4, 5, 6, and 7. So this is I0, I1, I2. All right. Now, first, what is the rule? You need to. This is W bar first, then W. First, you need to find out what are the places where you are getting this W bar. W bar means you are talking about 0. W means you are talking about 1. So ये W का column देखो, where we are having zeros. We are having zeros here. So main term 0, 1, 2, 3, 4, 5, 6, 7 पे W का value 0 है. Then 8, 9, 10, 11, 12, 13, 14, and 15, we are having W value as 1. Then provide the circle where you are having the mean where you are having F value as 1. So this is main term 0, main term 1, 2, 3, 4, then 10, 11, 14, 15. Now find the answer. For I0, I have circled the W bar value, so I will write W bar. I1 is also W bar. I2, see, it is W bar plus W. Both the components are present, so I will write it as 1. Here also, both the components are present, I'll write 1. This is W bar. None of the components are present, so I5 is 0. I6 will be W and I7 will be W. Now, your job is to connect. कहाँ पे देखो, फर्स्ट आई विल टेक W, ठीक है, W पे कौन कौन से वैल्यू कनेक्टेड है, I6 एंड I7. So I6 and I7 they are connected to W. Then W bar, W bar पे क्या क्या कनेक्टेड है, I0, then I1 and I4. So this is W, this is your W bar. Then I2 and I3, I2 and I3 पे लॉजिक वैल्यू 1 कनेक्टेड है. देन I5 पे 0, so I5 पे 0. So the same function can be implemented in two different ways. It can be implemented using a 16 cross 1 mux. Also, it can be implemented using the 8 cross 1 mux.
Ma'am,
Yes.
we can map any input, right?
Pardon?
We can map any input, right? For example, I have mapped Z.
No issue. You can take that. I have assumed here, no? I have written let. So I have taken XYZ. You can then take WXY as your input and Z is your, sorry, WXY को आप select line ले सकते हो, Z as input. That can be okay. Take any combination. You can take WXY as your select line. You can take XYZ as your select line. You can take WYZ as your select line. You can take WXZ as your select line. Whichever variable is left, you need to map that variable to your input values.
मैम
हाँ, in that case, answers will be different. Yes, tell me.
मैम इसमें से मतलब एमसीक्यू में तो नहीं हो सकता ऐसे टाइप्स.
No, we have given. We have given. And how we have given? Like not 16 values, but we have given for an example, f is equal to summation of the mean terms 0, 2, 4, 6, 7. Okay. So questions like the previous one, assuming two select lines, implement the function f and find the values of the input. So two select line means definitely it has to be, suppose say xy is the select line. So you must have mapped z as the input values. So what are the values? So options are like 0, 1, 0, 1 or 1, 1, 0, 0 or say w bar or say w, like this. Four possible answers are given. So question is ki you won't be having this much of a large example, but yes, examples like this, small examples you will be having. Okay, Amrit?
थैंक यू.
Any further doubt from anyone? Okay. All of you have noted down. Shall I move for the next example? I repeat. Shall I move for the next example?
Yes, ma'am.
Okay, write down. Question is implement the function f a b c. Amrit, please have a look. Here I have not given the mean terms, rather I have mentioned the function directly. Okay, so this kind of example you'll be having, or we will say implement two input XOR gate using a suitable mux. So what are the input values? Or implement two input NOR gate using a suitable mux. Okay, or say three input NOR, or say four three input XOR. So in that case, what you need to know, you should be knowing what is the behavior of the two inputs, or what is the behavior of three inputs, or what are the output expressions, okay, and which multiplexer value you should be taking. So here f is given as ab plus b complement c. Implement this using a 4 cross 1 mux. Okay, everyone. Now, question is that whenever you are having such kind of example, please check that are you having the function as the summation of the mean terms. If not, then please express it as the summation of the mean terms, because for the multiplexers, the inputs are always treated as the mean term values. ठीक है, जो भी select line लेते हो, 2 लो या फिर 3 लेते हो, accordingly you will be having the mean term expressions at the input. ठीक है. So here f is a function of ABC, means here c is not present, here a is not present. So I can write this one as ab, c not present, so c plus c complement, then a plus a complement, b bar c, a b c, c bar, a b bar c. So this is what mean term 7, then 1106, 101 is 5, 001 is 1. So we can write it is summation of the mean terms 1, 5, 6, 7. Okay, summation of 1 to 1, 5, 6, 7. Now अगर इसको डायरेक्टली 8 क्रॉस 1 को यूज करके करना होता, देन यू देखो इनपुट है 3 वेरिएबल, ठीक है. 3 वेरिएबल मीन्स आंख बंद करके इसको अगर क्वेश्चन में कहीं पे नहीं गिवन है, सो 8 क्रॉस 1 मार्क्स ले लो. इनपुट है 3 वेरिएबल, टेक दैट एज ए बी सी. ठीक है, 1 5 6 7, 1 5 6 7 पे 1 कनेक्ट करो, रिमेनिंग वैल्यूज पे 0 कनेक्ट करो. ठीक है, जहाँ पे जो रह गया, दैट इज द लॉजिक. लेकिन यहाँ पे क्वेश्चन में इटसेल्फ इट इज गिवन यू नीड टू इम्प्लीमेंट दिस यूजिंग अ 4 क्रॉस 1. सेम वे है, मैपिंग करना है हमें. ठीक है, सो फॉर द मैपिंग लेट अस प्रोसीड. लेट अच्छा, इस बार पहले वाला ले लो. लेट ए एंड बी आर सिलेक्ट लाइन्स. ठीक है, अगर ए एंड बी सिलेक्ट लाइन्स लिया गया है, देन दिस इज ए. यस,
Answer will be C0, C1. I mean, we will use C0 and 1 as input.
exactly. Your answer is C0, C1. Anyone, all of you have done it? Will I skip it, or I need to solve? Answer is right. It is C0, C and 1. Good. Rest of the people, shall I solve it, or you can do it by yourself? Say yes, say no.
No, ma'am.
Okay. All of you, please note down the answer. Your I0 is C, I1 is 0, I2 is C, and I3 is 1. It is a 4 cross 1 marks. and it is the F. All right. Write down the next question, please. Implement the following function using 8 cross 1 marks. Given f is a function of x, y, z, summation of the mean terms 0, 2, 3, 5. It's a direct question. Okay? Just draw the diagram, connect 0, 2, 3, 5 to 1 and connect rest of the values to 0.
Yeah.
Done? Yes, everyone. Done?
Yes, ma'am.
Okay. Write down the next question. Implement the following Boolean function. Implement the following Boolean function using an 8 cross 1 multiplexer, considering D as the input and ABC as the selection lines. Given f is a function of a, b, c, d, given as ab complement plus bd plus b bar c d bar. So here again, please check whether f has been given as summation of the mean term form. Yes, everyone. F is given as the summation of the mean term form. Yes or no?
No, ma'am.
Okay. In that case, what we need to do then? We need to express it as the summation of the mean term form. Okay. The same rule, everyone. Here, C and D are not present. Here, A and D are not present. Here, A is not present. So multiply the terms accordingly. First term पे C plus C bar, then D plus D bar. Second term पे A plus D. 0 0 1 0 2 1 0 1 0. Sorry everyone, I have muted myself. Okay. All of you have noted this question, 4 line to 16 line decoder.
Yes, ma'am.
So tell me, for a 4 to 16 line decoder, how many number of input line and how many number of output line you should have? Yes, everyone.
Um, 16 input line, 4 output line.
Or the reverse one. It is decoder, na?
Because, sorry, ma'am.
Decoder means you should have 4 number of input line. Okay. So say A, B, C, D. And you should have 16 number of output line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then simply you need to take the values for which your mean terms are present. Say F4. F4 is present for 2, 4, 8. So it is 2, 4, 5, 6, 7, 8. This is 8. Pass it through the OR gate and this is your F4. Similarly, F3 is 10, 11. So 0, 1, 2. So F3 is 10, 12, 10, 12, 13, and 14. Pass it through the OR gate and it is F3. Similarly, implement F2, it is 2, then 3, then 9 and 11. I do not have the space for F1 everyone. Please get it implemented. Drag the respective line, pass it through the OR gate and you'll be getting your output. Write down. The next question is design a 5 cross 5 to 32 line decoder from two 4 cross 16 decoders. Design a 5 to 32 line decoder from two 4 to 16 line decoders. So this is your 4 to 16 line and 4 to 16 line. So here I0, I1 up to I15 you'll be getting, then I16, I17 up to I31 you'll be getting. This is 4 cross 16, this is 4 cross 16. Now suppose say to the first decoder I have provided the input lines as A, B, C, D. So you can provide the same input line to your next decoder also. But question says you should have 5 number of input line and here we have taken only 4 number of input line. So the next input line I will take as the enable value. So here this is the enable. After passing through the Not get. Suppose say I'm using another element. Write down the next question. Design a 32 cross 1 box. Okay. Design a 32 cross 1 box using two 16 cross 1 box. So tell me, can you design it? Yes, everyone. Can you design it?
Only one.
Pardon?
We only have one output, so if we take two muxes, we'll have two outputs, right?
Exactly. Okay, that means you need to use another and one 2 cross 1 mux also. ठीक है देखो 16 cross 1 mux, so you'll be having I0 to I15, another 16 cross 1 mux, so I16 to I31. Select lines, same select lines A, B, C and D. But see, if you'll be taking two number of muxes, then you'll be having two output, this and this. But your question is you need to design 32 cross 1. Okay, so this output and this output must be combined together and it must be provided to 2 cross 1 mux. Since two number of inputs, so you need another select line, say E, and you are having one output here. Now see, the rule is if you are having 32 number of input lines, the number of select line has to be how much? Number of select lines has to be 2 to the power 5 is 32, so 5 number of selection lines. So see, here we have taken A, B, C, D, 4 select line and E is 5 select line. So overall, we have taken 5 number of select lines. We are having 32 number of input line and we are having one output line. Okay. Now everyone,
Ma'am, can you show that slide again?
yes, this one.
Yes, I'm done.
So everyone, please find the link for your quiz test in your chat box. Please respond your names. Raghunandan, Sai Pragya,
Present, ma'am.
Pritesh, Adarsh, M. Adarsh, Akash, Nishit,
Present, ma'am.
Ali Akhtar,
Present, ma'am.
Amlan,
Present, ma'am.
Amrit Aryan,
Present, ma'am.
Amrit Ranjan Sahu,
Present, ma'am.
Ananya Gupta,
Present, ma'am.
वैभवी नंदा,
Present, ma'am.
सौम्य रंजन चौधरी, हर्षवर्धन, हर्षवर्धन, अमृत, अमृत आर्यन.
Yes, ma'am.
Could you please send me the number of Harshvardhan? Do you have?
Wait, ma'am.
If you are having, then please send me the number over the WhatsApp only. Okay. So Dhanya Jai Singh,
Present, ma'am.
Kartikeya Singh,
Present, ma'am.
Nihar Ranjan Nayak, Ranit, Ranit Mazumdar, Rishikesh Sarangi,
Present, ma'am.
Rishikesh Mishra, Rishikesh Mishra, Rishu Kumar, Pratik Raj,
Present, ma'am.
Lipsita Sahu,
Present, ma'am.
Sakshi Sinha,
Present, ma'am.
Samrat, Samrat Mukherjee,
Present, ma'am.
okay. Sanket Pradhan,
Present, ma'am.
Present, ma'am.
Vijay Santosh,
Present, ma'am.
Priyadarshini, Swapnesh Pathi,
Yes, ma'am.
Akash Sen,
Present, ma'am.
ठाकुर दास.
Present, ma'am.
ठाकुर दास, आपने yesterday सबमिट किया असाइनमेंट?
Yes, ma'am. कर दिया.
ओके. और इसको आपने इंटीमेट किया था क्या हर्षवर्धन को?
Ma'am?
हर्षवर्धन को इंटीमेट किया था, उसने भी नहीं सबमिट किया. यस.
नहीं, ma'am.
से बात नहीं हुई है आपकी?
नहीं, ma'am. बात नहीं हुई.
ओके, ठीक है, कोई बात
Okay.
नहीं. और जसवी,
Present, ma'am.
प्रीतम,
Present, ma'am.
विशाल रॉय,
Present, ma'am.
शोभित राज,
Present, ma'am.
प्रज्ञा परमिता,
Present, ma'am.
स्वाति,
Present, ma'am.
नवनीत,
Present, ma'am.
दिव्यज्योति, दिव्यज्योति, ओके. शाश्वत,
Present, ma'am.
ऋचा,
Present, ma'am.
बिरजा शंकर,
Present, ma'am.
साहिल जायसवाल,
Present, ma'am.
पवन वर्मा,
Present, ma'am.
किनकिनी करण,
Present, ma'am.
आयुष अग्रवाल,
Present, ma'am.
आदित्य राज ठाकुर,
Present, ma'am.
रोहन तराई,
Present, ma'am.
सुब्र प्रसाद,
Present, ma'am.
विशाल मेहता, अमित प्रधान,
Present, ma'am.
शैलेश नायक,
Present, ma'am.
विश्वजीत बिस्वाल,
Present, ma'am.
अध्यस्मिता प्रधान, राज रौनक,
Present, ma'am.
सत्यम वर्मा, सामनी, रशीद, सौम्यजीत बोरा,
Present, ma'am.
अनिमेश कानूनगो,
Present, ma'am.
पूजा साहू,
Present, ma'am.
आयशा रथा, प्रत्युष प्रियदर्शन, हिमांशु हाथी, ऋषिकांत. Okay. So, if anyone is having the contact number of Himanshu Hathi, Divyajyoti Patra, and Harshvardhan, please send the number of these three students to me because I haven't received the assignments and the quizzes. Sorry, theory and lab assignment from three of them. Otherwise, they'll be marked as absent. Okay. So with this, we shall conclude. Since this is the last day of interaction, all of you please do well in your end semester examination. Okay. All the best to everyone. All right. Any
Thank you, ma'am.
queries, any doubt, any suggestion, any opinion from your side? No, no comments? Okay. Pratyus, Aisha, Adya, Smita, Rishi, Mishra, Samrat, Nihar. Okay. Hmm. Ranit, what is it? Okay, so thank you everyone. Okay, with this we shall conclude the class. Okay, all the best.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Okay, good morning everyone. So this is CSE section R, and today we're going to be learning about the discrete Fourier transform using the divide and conquer approach. So I'm sharing my screen with you right now, and we're going to take a look at this concept. Okay, so discrete Fourier transfer. Suppose we have an expression x of n. Okay, now suppose this index, suppose n can be written as a product of L and n. In that case, suppose you have the sequence x of n. It is x0, x1, x2 till x of capital N minus 1. Now it can be represented as a two-dimensional array x of Lm, small m, where small l being the row index and small m being the column index. So here you can see there are 0 to L minus 1, so L number of rows, and 0 to m minus 1, so m number of columns. So I hope everything is clear so far. Now these are the elements x0, 0, that is for n equal to 0 and m equal to 0. And since n equal to L into L multiplied by m, so when L equal to 0 and m equal to 0, then x of 0, 0. Like there are two other relations. Suppose n equal to m L plus m. In that case, there will be row-wise mapping of x of n and x of Lm. X of Lm is the two-dimensional array representation of the sequence x of n. So you have x of n like this: x of 0, x of 1, x of 2 till x of n minus 1. Now suppose m equal to m of L plus n. Then according to row-wise mapping, here also we are getting L minus 1 number of L number of rows and m number of columns. The total number of elements should be Lm. Now here in each row, the first m elements of x are placed. Like in the 0th row, x of 0 till x of n minus 1, m number of elements. In the 1th row, or the row with the index or the row with the index 1, from x of n till x of 2m minus 1. So once again m number. So in each row, m number of m elements of x are placed. Now suppose you take an example of this cell. So here L equal to 0 and m also and m equal to 0. So if you substitute these values here, then n equal to 0. So x of 0 is inhabiting this cell. Now suppose you take the example of this cell. Okay. So L equal to, here L equal to 1 and m equals here L equal to 0 and m equals to 1. So substitute that value here. So you get x of 1. X of 1 is inhabiting this cell. So now this is the representation of the row-wise mapping. Now take another scenario that leads to the column-wise mapping. Suppose n equal to small l plus ml. Okay. So here in each, and this is the sequence x of n. Then in each column of the two-dimensional array, when it is presented in this tabular manner, then in each column we place the first L elements of x. So in the 0th column, from x of 0 till x of L minus 1 is placed. In the 1th column, from x of L till x of 2L minus 1. So here total L number of elements are there in each column, and the total number of elements is going to be obviously L multiplied by m. So this is the column-wise mapping. Now take a look at the divide and conquer approach. So suppose you have the DFT values x of k. So like x of n was a sequence. So similarly x of k is going to be such that k is something between 0 and n minus 1. So this is a one-dimensional array of index k. Now this can be represented as, just like we are representing x of n as x of lm. So we are representing x of k as x of p and x of q. Now p and q being the row and column index respectively, such that p value is from 0 till l minus 1 and q value is from 0 to m minus 1. So now according to row-wise mapping, if when x of n was being converted to x of lm, Okay, then n equal to ml plus m, and in another scenario when we have column wise mapping, it was n equal to small n plus, here you can see small n plus small m into capital N. Similarly, L and M are replaced by P and Q, and N is replaced by Q. So you will get the conditions for row wise and column wise mapping. Now we talk about the twiddle factor. What is the twiddle factor and what are its properties? So now the twiddle factor is given by is noted by the notation W of n, and the value of W of n is e to the power minus j2 pi by n. Okay, so it has the twiddle factor, also known as the phase factor. It has two properties: the symmetry property and the periodicity property. Now what is symmetry property? So take a look at this expression: f of n to the power k plus n by 2 equal to minus of W of n k. Now you can also prove that by simply expanding. You know that W of n equal to e to the power minus j2 pi by n. So when you place that value here and you expand this, then you get this value. So this is the proof for symmetry property. Similarly, you get the proof for periodicity property as well. Now we consider the column wise mapping for x of n, okay, and row wise mapping for x of k. So now what is the expression for x of k? In x of n, the expression was summation n equal to small n equal to x of small n equal to summation n value would be from 0 to capital N minus 1 x of n w of n to the power kn. That was the value. Now when x of k is being represented as a two-dimensional array x of pq, then the values are going to be substituted accordingly. Okay, so m value is from 0 to m minus 1 and l value is from 0 to l minus 1. Okay, and x of lm and k and n values are replaced like this. K was mp plus q in row wise mapping of x of k, and in the column wise mapping, what is the value of n? L plus ml. So the values are substituted accordingly. Now this part is expanded. This part is expanded and we get something like this. Now we try to shorten this by solving these expressions individually. You take the example of this one, suppose w of n to the power ml mp. Now l into m equal to n, capital N, so we write n here. Now w of n equal to e to the power minus j2 pi by n. So when we write e to the power minus j2 pi by n and n gets cancelled, to e to the power minus j2 pi, that value is going to be 1. So 1 to the power this mp, it gives 1. So 1 is the value of this equation, of this expression. Now we take a look at this expression, w of n qml. So w of n qml, if you substitute w of n as e to the power minus j2 pi by n, and since l is multiplied here, so l gets divided, can be written as e to the power minus j2 pi by n by capital N. So if w of n equal to e to the power minus j2 pi by n, then what will you write e to the power minus j2 pi by n by l? What will you write e to the power minus j2 pi by n by l? You will write it as you write it as w of n by l, and qm remains as it is. Now you know that n equal to l into m, so n by l becomes m here. Now we take a look at this expression, w of n to the power mpl, the first expression. Here also it can be rewritten as, if you substitute e to the power minus j2 pi by n, then you get w of n by m and p and l. Okay, and n equal to lm, so n by m equals to l. So you substitute these values here, and we're going to do some rearranging. So you get the m part as here and l part as here. Now we're going to take a look at how we expand and solve this expression. So x of pq equals to l equal to, that is the row index, I suppose. Yes, it is the row index from 0 till l minus 1, w of n to the power lq, and this is the column index m, So now first you try to solve the expression inside this bracket. So this will be summation m equal to 0 to m minus 1 x of lm w of m to the power mq, where q value is from 0 to m minus 1. Now you notice this, friends, whatever may be the value of m, okay, for m it is from 0 till m minus 1. What is it that we are computing here? You are aware of the formula of DFT, so here we are computing the m point DFT for each row, okay, whatever may be the value of L. For L equal to 0, so we are going xx 0m, we are computing the m point DFT for the 0th row. For L equal to 1, you are computing the m point DFT for the first row. Then you find the rectangular array. Okay, how do you find rectangular array? Now this is this expression that we are calculating, we are storing it as f of LQ. So you are computing the rectangular array by multiplying w of n to the power LQ by this f of LQ. We are writing this expression as g of LQ. Okay, and these are the this is the value range of L and Q. Then you compute the L point. Then you compute this whole part. This whole part would be this. This was f of LQ, and when this is multiplied, it is becoming g of LQ. So this whole expression is written as g of LQ multiplied by w of L to the power PL. L value from 0 to L minus 1, and this is the value range of P. So what are we computing here? This was here you are computing the m point DFT for each row. Here you are computing the L point DFT. This is WL. So you are computing the L point DFT for each column. Whatever may be the value of L, for the value of Q, for Q equal to 0. So for 0th column you are computing the L point DFT. For Q equal to 1, then for first column you are computing the L point DFT. So this is how you are going to compute the expression. Now if you try to look at the number of multiplications, because we are going to make a direct comparison between this divide and conquer approach and the direct approach or the lengthy approach. Now in divide and conquer approach, you take a look at this step 1. How many number of multiplications are required here? Here we are computing m point DFT. Here we are calculating the m point DFT. So for one m point DFT, the number of computations is m, capital M. Okay. So for one row, the number of multiplications required to calculate the m point DFT is capital M. We are doing that for L number of rows. The total number of multiplications would be Lm. And then, sorry, there is a mistake here. For computing the m point DFT for one row, the number of multiplications is Lm. Okay, the number of multiplications. Then you take a look at step 2. How many number of multiplications are happening here? Here only one. Here you are computing. Here the m point DFT that you are getting here, you are storing it as f of LQ, and in g of LQ calculation, you are multiplying w of n to the power LQ with this expression here. So what is the cost of computation? If L signifies the row, the number of rows, and M signifies the total number of columns. So the number of multiplications required here is Lm. Now you take a look at this part. For calculating the L point DFT for one column, the number of multiplications required is, what is the number of multiplications required? So we are calculating the L point DFT for one column. For one column, you are getting it as L square. Okay. And how many times you are calculating that? For total m number of columns. So m multiplied by L square. So you get it as total number of multiplications as ml square. So these are the total number of multiplications. You add this and you get the value as n into m plus L plus 1. Now in the direct method, it is more than that. So this is almost half of it. Now we take a look at how we find the number of additions. We take a look at step 1, f of LQ equal to this expression. So how many additions are happening here? When q equal to from 0 to m minus 1, how many additions are happening here? you're getting m all m minus 1 additions for a single L value. Okay, for L equal to 0 or for L equal to 1 or L equal to 2, you get m all m minus 1. So what will be the total number of additions? The total L number of rows. So L multiplied by m all m minus 1. This is the total number of additions. And how are you getting the zero number of additions in step 2? In step 2 we are only doing the multiplication. There are no additions here. So there is 0. And in step 3, just like in step 1, in step 3 to compute the number here we are doing L all L minus 1 number of additions when we are computing the L point DFT for a single column. When we are computing the M point DFT for a single row, the number of additions was m whole m minus 1. So for L number of rows, it was L multiplied by m whole m minus 1. Similarly, for a single column, the number of additions to compute the M point DFT is L whole m minus 1. To compute the L point DFT is L whole L minus 1. For m number of columns, it is m multiplied by L into L minus 1. So what is the total number of additions here? You get n whole m plus L minus 2. In the direct approach, this is going to be something as n into n minus 1. So obviously this is an improvement over the direct approach. So this was the direct Fourier transform, how to find the DFT coefficients using the divide and conquer approach. Now I think I should take the attendance, and I'll be sharing a link with you. I hope this was clear to everyone. Now I'm going to be sharing one link with you. So there are some questions. Now this is not going to be an evaluation, so no need to panic. This is not an evaluation. These questions are simply for your practice. So you have about a half an hour. Let me just share the link. Okay, so there are 4 questions here, and you have about half an hour to solve those. So this is my practice, and I will be taking the attendance anytime. So no connecting at the last hour. Okay.